6,200 Andy. That is the number of OpenAI engineering jobs in India on Glassdoor right now in June 2026. Every single one of them mentions LLMs, AI agents, or agentic AI. And here is the uncomfortable truth. Most developers applying for those roles cannot explain the difference between the three. Not clearly, not in a system design round, not in a way that gets them hired. This is not a vocabulary problem, it is an architecture problem. If you cannot draw the line between an LLM, an AI agent, and agentic AI, you cannot design the systems that companies are building right now. You cannot contribute to the team, and you will fail the system design round. Not because the interviewer is being difficult, but because you genuinely do not know what you are working with. These roles pay between 12 and 40 LPA depending on experience. The job postings requiring these skills grew 300% in 15 months. The window is open right now, but only for developers who understand what they are building. 3 terms, 10 minutes. Let's fix this. Let's start with the foundation. An LLM, large language model, is a deep learning model trained on massive amounts of text. It takes text in. It returns text out. That is the complete boundary of what an LLM does on its own. No memory, no ability to run code, no awareness of what time it is, no way to take action in the world. Here is the analogy that makes this stick. Think of an LLM as the brilliant consultant in the boardroom. They have read everything. They can answer any question, they give you perfect analysis, but they cannot file the paperwork. They cannot call your vendor. They cannot push the commit. The moment the meeting ends, they forget you were ever there. That last point is the one most developers miss. An LLM is stateless by default. There is no persistent entity remembering you between conversations. When you open ChatGPT and it seems to remember your last message, it is not actually remembering anything. The interface is secretly appending your full conversation history to every new API call. Every single call starts from zero. The LLM is freshly reinstantiated each time, reading the entire transcript as context. Think of it like this. Imagine if your database reset itself after every query, unless you explicitly pass the last state as a parameter. That is exactly how an LLM works. The intelligence is real. The memory is an illusion built by the application layer. So when someone says, I am building with AI, if all they are doing is calling an LLM API with no tools, no memory system, no loop, is they have a very smart function. Nothing more. Now take that LLM and give it hands. That is an AI agent. An AI agent wraps the LLM in a control loop and attaches 3 things. Tools it can call, search engines, databases, code execution, APIs, memory, so it can accumulate context across steps, and a goal it must pursue across multiple reasoning steps. The loop looks like this in developer terms. While the goal is not met, the model reasons. It picks a tool. It calls the tool. It observes the result. It reasons again. It acts again. It keeps going until it is done or runs out of budget. This is called the react loop, reason and act. It is the core pattern behind every serious agent framework in 2026 LangGraph, Crew AI, the Anthropic SDK. The analogy, the LLM, is a senior developer who gives excellent code review feedback in a meeting. The AI agent is that same developer with an IDE open. Same brain, but now they can actually read the code base, run the tests, and push the fix. Same intelligence, radically different capability. An LLM knows everything but can do nothing. AI agent can do things. Agentic AI gets things done. Memory is the piece most developers skip. Agent memory comes in 3 types. Working memory is the current conversation context. Episodic memory is a log of past runs. What the agent tried, what failed, what worked. Semantic memory is long-term facts stored in a vector database. The things the agent should always know, retrieved on demand. None of this is automatic. You have to build every layer of it. AI agent is one capable worker with a goal loop and tools. Agentic AI is the whole company. Definition: a system where multiple AI agents, each with its own specialization, tools, and model, coordinate through an orchestration layer to complete complex, long horizon tasks. Here is how it works in practice. You have a researcher agent that gathers data from the web. It's a writer agent that drafts content based on that research, a QA agent that checks the output for accuracy, and an orchestrator agent, the project manager, that assigns tasks, evaluates sub-agent outputs, and reroutes when something fails. The orchestrator does not do the work. It manages the handoffs. The analogy: a single AI agent is a skilled freelancer. Agentic AI is a consulting firm. Multiple specialists, a project manager, a QA reviewer. You brief the PM, the firm delivers. This architecture is what allows agentic AI to tackle tasks that would break a single agent. A single agent hits context window limits on complex tasks. It hallucinates when asked to track too many variables at once. A well-orchestrated multi-agent system routes each subtask to a specialist that can handle it cleanly. The key distinction from just running multiple LLM calls in parallel: agentic AI requires coordination with goal-directed handoffs. A parallel LLM calls with no shared memory, no feedback loops, no task routing, that is just batching. The defining property is orchestration. One more thing: agentic AI is not fully autonomous by default. Autonomy is a dial, not a switch. At one end, as the LLM advises and a human executes every action. At the other end, the system plans, acts, and self-corrects with zero human involvement. Most production enterprise deployments in 26 sit deliberately in the middle, 40 to 70% autonomy, using human in the loop or human on the loop patterns for compliance and risk management. Let me show you what this looks like in the real world, and I mean real, with real money on the line. On May 27, 2026, a Robinhood launched Agentic Trading, not an assistant that tells you what to buy, an agent that actually buys. Here is exactly what happens under the hood. You set a goal, for example, rebalance my portfolio to 60% equities, 30% bonds, a 10% crypto based on this week's market signals. The orchestrator agent takes that goal. It routes to a market research agent that pulls current prices, news, and signals from live APIs. A risk assessment agent evaluates your portfolio exposure and checks your stated risk tolerance. A trade execution agent constructs the orders. The orchestrator reviews the proposed trades against your goal, and if you have opted into autonomous mode, executes them. Not here is what I would do. It did it at 9:32 a.m. This is the LLM to agentic AI progression made visually concrete. For years, this level of algorithmic trading required a Bloomberg terminal and a team of quant engineers. The intelligence was always there, in the research. What changed is that the agent layer gave it execution power, and the multi-agent layer gave it the coordination that no single model could reliably sustain. Notice the governance design. Robinhood does not default to fully autonomous. You must explicitly opt in. The system defaults to human on the loop. The agent proposes, you approve high-value actions. This is the architecture that makes regulators and risk teams comfortable enough to ship. And this is the pattern showing up across every serious enterprise deployment in 2026. Not let the AI decide everything. Supervised autonomy. The agent handles the complexity. Humans stay in control of the consequences. 6 mistakes. Know these before your next interview. 1. ChatGPT is an AI agent. No. ChatGPT with no tools, no browsing, no code interpreter is just an LLM interface. It becomes an agent only when tools are attached and the agent loop is active. Saying I've worked with AI agents like ChatGPT without specifying tool use is the number one red flag interviewers screen for in 2026. 2. LLM equals AI. An LLM is one subcategory of AI. Computer vision, fraud detection, recommendation systems, speech recognition. None of these involve LLMs. Conflating them is like saying software equals mobile apps. 3. Agentic means autonomous. Autonomy is a spectrum. A system that drafts emails but requires human approval before sending is agentic. A system that executes trades without approval is autonomous. Most production systems deliberately sit in the middle. 4. AI agent and agentic AI mean the same thing. One agent is one agent. Agentic AI is multiple agents with a coordination layer. The distinction matters as much as a function versus a microservices architecture. 5. More agents equals better. More agents multiplies token costs, latency, and failure surface. A well-designed single agent often outperforms a poorly orchestrated 4-agent crew. The right question is never how many agents. It is what is the minimum architecture that reliably solves this problem. 6. Memory is built in. It is not. Memory must be explicitly architected. Working memory, episodic memory, semantic memory, all separate components you design, store, and retrieve yourself. Developers who skip this end up with agents that forget user preferences, repeat work, and contradict their own prior conclusions. 3 terms. 1 architecture hierarchy. The developers who understand this are building systems that are reshaping entire industries and averaging 23.4 LPA to do it. The ones who mix up the terms are getting filtered at the system design round. Now you know the difference.